Hello, this is Christopher Chisholm with the Gas Laws Project and the project. So, combined gas laws. Combined gas laws is P1 times V1 over T1 is equal to P2 times V2 over T2. The term STP stands for the standard temperature and pressure. Mathematically, this means 1 atmosphere pressure or 760 mmHg or 101.3 kPa and or zero point 0.0 Celsius or 273 degrees Kelvin. My problem would be a 6.5 liter tank of methane gas has compressed gas in it, so the pressure is 2,500 kPa. What will the pressure of the gas be if the gas is put into a 3.25 liter tank? So 2,500 over times 6.5 over 3.25 is equal to P2, and then there's the math, and P2 turns out to be 5,000 kPa. And over here you can see that I got V1 is equal to 6.5 liters, P2 is equal to 2,500 kPa, and V2 is equal to 3.25 liters, and P2 is what we're trying to solve for. So as I said, P2 is 500 kPa, and my math would be 3.25, and then you divide it by 3.25, and then you get your answer of P2 being 5,000 kPa. Boyle's law. Boyle's law increases the pressure is equal to decreasing of the pressure of the volume, and decreased pressure equals increased volume. Real life application of Boyle's law is a football is inflated inside and then taken outdoors on a winter's day, and it shrinks slightly. So, and my problem is P1 times V1 is equal to P2 times V2. So 1.454 times 3.12 is equal to P2, which we're solving for, times 5.25. So as you can see, P2 turns out to be 1.54, 3.12 over 5.25. P2 finally turning out to be Charles' law. Increases temperature equals increased volume, decreased temperature equals decreased volume. Real life application is if it's cold outside, you may notice that a helium balloon has crumpled. All isn't lost, of course, because once you enter a warm home, the balloon returns to its original shape. This is because, according to Charles' law, gases take up more space when they are warm. In Charles' law, increased temperatures equals increased volume, decreased temperatures equals decreased volume. And here's my graph, and I forgot to mention the graph on the other page. And then the equation is a 23.8 liter balloon is filled with 88 grams of CO2 and 15 degrees Celsius. What is the pressure in kPa? There's all the work there for the problem. Gauge's law. Gauge's law increases temp equals increased pressure, decreased temp equals decreased pressure. Real life example is firing a bullet. When gunpowder burns, it creates a large amount of superheated gas. The high pressure of the hot gas behind the bullet forces it out of the barrel of the gun. So, the equation would be V1 over T1 is equal to V2 over T2, and then there's the graph. 864 liters over 340.6 Kelvin is equal to 10 times liters over T2. And then there's the work, and T2 equals 3.94 Kelvin. Avogadro's law. Avogadro's law, increased number of moles is equal to increased volume. Decreased number of moles equals decreased volume. A real-life application, as you blow up a basketball, you are forcing more gas molecules into it. The more molecules, the greater the volume the basketball inflates. So I have my equation here, which is 5 moles over 2 liters is equal to 10 moles. Dalton's law. P total equals PA plus PB plus PC plus for however many gases you have. What is the unit? What if the units are not the same? Convert the same unit using the dimensional denalysis. Real life example: air is a mixture of nitrogen, oxygen, carbon, and hydrogen, etc. Each of these gases has its own particle pressure total up to the atmospheric pressure at the location. The particle pressure of the water in the mixture can be translated into the humidity of the air. So there's my problem. The total pressure of the gases mixture is 0.91 atm, and the mixture is known to contain 0.050 moles of N2. Calculate the particle pressure of the oxygen and the moles in the oxygen. And then there's all the work, as you can see. And so that would be Dalton's law. So thank you for your time.